7 o'clock in the morning. It's completely up to you. So that is a nice feature. Another little tip is when you watched the orientation or you were in the orientation class, I did give you an orientation assignment on the Moodle website. The Moodle website is a great spot for you guys to go to and find information from the class. Any pictures, any PowerPoints we talk about during class is going to end up on that website. The orientation assignment, 5 of you finished. The rest of you didn't do it. So if you could just go ahead and do it at some point within the next day or two for me. It's very simple. It just asks your name and your favorite kitchen chemistry topic. There are going to be a few times this semester when I can add a 5 or 10 minute lesson, and I want to add something that interests all of you because it is your class and I do want you to enjoy the class. Then you're just going to click submit, and that shows me that 1, you've been to the website, 2, you know how to submit an assignment to me, and 3, I now know your favorite chemistry topic, and I can hopefully include that in this class. So does anyone have any questions about this class before we go ahead and technically get started?
No, not me. Not me.
Oh, wonderful, Alana. I was able to hear you that time. Great. So let's go ahead and get started if no one has questions. Right now on your whiteboard, which is the bottom right-hand rectangle, you should see a picture of a giraffe. Actually, 2 very similar pictures of 2 giraffes. What I'd like you to do is go ahead and make this picture larger. To make the picture larger, you hit the arrow that is pointing up to the right on the purple toolbar. Now my picture should go away. It's actually just hidden behind that screen, and you should see these pictures. I'm going to allow you all to write on the whiteboard, which I just did, and I would like you to try to find the differences between these 2 pictures. So I'm going to go ahead and do the first one for us. There is a line on that giraffe's ear, but not on this giraffe's ear. And I just went ahead and circled them in green. Observations are a very important part of science, and especially in this course, we are going to be observing lots of things throughout time, comparing them to temperature, comparing it to a wealth of information. So I see someone just circled a coconut. Go ahead and take a couple of minutes and write or circle differences you see between the 2 pictures. To circle something, the 4th button down is a circle. You can click on that circle and then click on the whiteboard and you should be able to make the circle. Or the 5th button down is a pencil. If you click on that pencil and then click on the whiteboard, you can draw right on the whiteboard. So go ahead and take a couple of minutes. All right, I see some great observations up here. We're going to take about 1 more minute. So if you see any, either circle them or you can just write it on the bottom if that's easier for you.
We just found what we're looking for. Can you
Yes, hold the
repeat
button
that
again, honey.
again?
Yep, you can go ahead and just circle right on the whiteboard, or you can go ahead and write the differences you find on the bottom. Either one is perfectly fine. Okay, and with that last circle, I believe you guys have found all of the differences between my two giraffe pictures. Great job. The observation that you guys just made is all with your eyes. We didn't use any other senses when making these observations. In science, you lots of times are using multiple senses to make observations. What we are going to do right now is we are going to talk about making a few observations. Oh, and I see one more that you guys missed. Let me go ahead and I'm going to circle it in red. The giraffe on the left, his spot does not reach the edge of his neck. And on the right-hand side of the picture, it does. Fantastic job. You are one of the first classes to get all of those observations so quickly. Now what I would like you to do is we need to make this picture smaller again, because now I need you to be able to see me and see my PowerPoint screen. So in order to do that, you see a purple toolbar across the top of your screen, and it has an arrow pointing down now. If you click on that arrow, oh, my camera froze, hold on. If you click on that arrow, you should be able to see all 4 PowerPoint screens now. Or all 4 rectangles, I'm sorry. Let me reload my camera here. All right, I'm going to have to work on my camera for a second here. While I'm working on my camera, we're going to start looking at a presentation. Now, we're going to talk about observations. So I'd like to hear from you guys. Go ahead and raise your hand if you can think of a way that you could make observations in a science course. Can anyone come up with a way? Alana, go right ahead. How can you make an observation?
Knowing which leaves are which, and seeing how big they are to each other.
Very good. Comparing the size of things. That's a great observation. Can anyone else think of a way you can make an observation in a science course or just in general? Go ahead and raise your hand. All right, Brooklyn, you're next. Go ahead.
Or touching things.
Very good. By touching things, you can use your sense of touch. Great job. Xana, let's hear from you.
Smell.
Very good. Using your sense of smell. Fantastic. Alana, did you have another way?
Seeing how fast things can be.
Excellent. Seeing how fast things can be. Great job. Those are all great ways to make observations. Now, I made a little PowerPoint here. We already talked about a few of them, so we'll just skim right through this. On your screen, on the top right, you should see something that says observations. We observe things using our 5 senses, and then I put a picture up here. Now, you can make this screen larger as well by clicking that up arrow that's in the purple toolbar. You can leave it smaller. It is completely up to you. When we look at a picture like this, we can really only observe using our sense of sight. However, if we were in the jungle by that waterfall, we could use all of our senses. So our sense of sight is the one we use most often, using our eyes to determine something, like the color, the size, or the shape of something. We can also use our sense of hearing. We can use our ears to determine if something is loud or high-pitched, if something is quiet. My house right now, it's very windy outside, so I can hear the wind. I can't really see the wind. I can see the leaves blowing across my front lawn, so I can assume it is windy out, but I can hear it. Smell. We use our sense of smell to determine things, if it's stinky or if it's sweet smelling. Now, a word of caution. In science class, you don't ever want to smell things unless you are told to smell things. Sometimes smelling something can prove to be very dangerous and it can make you sick. So, if you're doing some sort of experiment at home, be careful about smelling things. Taste. Taste is definitely a sense that we use. I can taste that my coffee is sweet when I put creamer in it. Or I can taste that a Sour Patch Kid is sour. Again, not an observation or a sense that we use often in science. You don't want to be tasting chemicals. Most of them will make you sick. Touch. We can use our hands to determine if something is sticky. I know the desk I'm sitting at is hard because of my sense of touch. Now here's a picture of a beach. What are some observations that you can make about this beach? Go ahead and raise your hand. Go ahead, Alana.
What did you say? She can't see you. Did you eat one of those chemicals?
Can you tell me an observation that you can make from the picture on your screen of the beach? Go ahead and raise your hand if you can make an observation. Go ahead, Alana.
Say, what are you eating? My Wonka. Water. Wonka. What's a Wonka?
All right, Shelby, would you like to try? Can you make an observation of the picture up on the screen?
When it's really hot out when you go to the beach so you can feel the hotness.
Okay, that would be an observation. It looks hot out. The people are walking on the beach. It's sunny out. That is a good observation. Can anyone make any other observations? All right. Brooklyn, go ahead and give it a try.
Sea and the trees. You can see them.
Very good. We can see the ocean or the sea and some trees. All right. Alana, you want to give it another shot? What's an observation?
I thought it was supposed to be this way, but instead it's supposed to be this way. Feeling the waves.
All right. Good job. The waves. That's a good observation. And for our last observation, Ian, why don't you make an observation about the picture on the screen? All right, Ian, in order to talk, make sure you hit the green talk button that's on the bottom center of your screen.
Okay, go ahead. You can see that the blue water is there. You can see that the people at the beach. And you can see the trees. And you can see the beautiful rocks.
Awesome, great job. You can see the people and the trees and the blue water, and I believe you said the rocks. Great job. Those are all great observations. Today, when we are doing our investigation that we're going to do, you are going to have to pay attention to some observations. Now, what we are going to do today is we are going to do a lab, an activity that we use Alka-Seltzer, hot water, and cold water. So what I'd like everyone to do right now is take a minute and go and get some hot water. Your water does not have to be boiling. I'm going to use hot water, tap water out of my sink. So just go get a half a cup of the hot water for our lab. And then we will come back and we are going to go ahead and get started on our first kitchen chemistry activity.
Four pictures.
I'm sorry, I didn't hear that whole thing. Can you repeat that?
We're not getting four pictures right now. All we're doing is seeing you and the two giraffes.
All right, so you just see me, and I actually just erased the giraffes. So right now, what two screens are you seeing? You should be seeing me, hopefully, and a PowerPoint that says effects of temperatures on reaction rates by chance?
No.
No, we are just seeing you.
All right, hold on one second. Am I huge on your screen? Like on the top of me, see if there's a purple toolbar. And if I'm huge, there should be an arrow clicking down and to the left. If I'm not huge, if I am huge, go ahead and click that and see if then you see two screens.
Arrow. She's huge, but I'm still looking for an arrow and I don't see it.
Look over me, there should be a purple toolbar or blue toolbar, depending on your color settings on your computer. And on the far right of that toolbar, there should be an arrow, kind of a curved arrow. And if it's pointing down and to the left, click on it, and then it should make me smaller again. Did that work? Okay, I'm going to go grab my hot water. I just sent you all a poll. Click yes when you have your hot water. Okay, if you're not going to do the labs along with me today, that is perfectly fine. I completely understand. However, just go ahead and click yes so I'm not waiting for you. All right, perfect. Everyone is all set. Now, one thing to remember in this class is I am going to do all of the activities live for you. You are more than welcome, and it would make it a better class if you do them along with me. For safety reasons, I am always going to wear a pair of safety goggles during lab. If you have a pair, a great idea to wear them. You never know what could splash up into your eyes. For today's activity, if you don't have a pair, I wouldn't worry about it too much. Just be extra careful. If you need a pair, your local hardware store has them. They're usually only $1, $2. They're not expensive. Definitely an investment worth making. So I'm going to take a second and put mine on. They definitely are not comfortable or stylish, but they will protect my eyes should something splash into them. And we are going to go ahead and get started. Now, up on your PowerPoint screen, the name of this activity is the effects of temperature of reaction rates. So a little bit of background information, which I like to give everyone when we are starting a class, is that in order for a reaction to occur, there's particles, atoms, and ions that are reactants. Reactants are things that come in contact with each other. So for example, our reactants are going to be Alka-Seltzer and water. Those are our two reactants for today. What the Alka-Seltzer and the water form when they join is called a product. Anything that increases the frequency of these encounters will increase the rate that the products are formed or cause the reaction to occur quicker. Now today, we are going to be testing to see if temperature has anything to do with how quickly Alka-Seltzer will dissolve in water. To do that, we are going to use some room temperature water, some ice mixed with water, and some warm water that we've got. If at any point you guys have a question during this lab, please go ahead and raise your hand and I will go ahead and stop. My goggles are fogging up. Let me clean them quick. All right, Mallory, go right ahead.
I didn't get the ice or the room temperature water.
Okay, I'll pause for a second. If you don't have your ice water or your room temperature water or your Alka-Seltzers, go ahead and grab them. And I'll set up another poll, and when you're ready, just click yes. All right, once you have everything, just click yes. If you're not doing the lab along with me, just click yes now so that we do not wait. All right, it looks like we are all set to go. So whenever we are doing an investigation or a scientist is doing a lab or conducting an experiment, we need to make a hypothesis. That is our first step. I went ahead and wrote most of the hypothesis sentence here. You just need to fill in the blank. And I would like you to think about what you know about hot water and cold water, and maybe what you know about Alka-Seltzer. Now I'm going to give you a little bit of information about Alka-Seltzer because it may be that you know nothing about Alka-Seltzer. So Alka-Seltzer is used if you have an upset stomach or acid indigestion. You would just kind of feel your stomach feels bubbly. And what it does is it calms an antacid. It calms the acids in your stomach. However, what it does when I drop it in water, and I'm going to show you guys right now, I do not want you to be doing anything right now. I'm going to take an Alka-Seltzer pill and drop it in room temperature water. And I want you to see what it does. It is bubbling. Now your hypothesis is, as the temperature of the water increases, the rate of the reaction, so the length of time it takes for that entire Alka-Seltzer tablet to be dissolved, will, and here is your choice, increase, decrease, or stay the same. So as I add heat to this water, as I make it either hotter or colder, is the tablet going to dissolve faster or slower? So if you think the tablet will dissolve faster in hot water, your hypothesis will be, as the temperature of the water increases, the rate of the reaction will increase. If you think that it will slow down, as the water gets hotter, your hypothesis will be, as the temperature of the water increases, the rate of the reaction will decrease. And if you're not sure, you're going to write, as the temperature of the water increases, the rate of the reaction will not be changed. So those are your only three options. So please make a hypothesis. Okay, when you're done with your hypothesis, go ahead and click yes. Just jot it down on a piece of paper so that you know what your hypothesis was. And we are going to test them out. You also need some sort of watch. I am going to use the timer on my phone as my watch. You need a second-hand watch. So this is what I'm using. Go ahead and grab yours. You can use a regular clock as well. All right, just waiting for one more hypothesis. All right, we've all made our hypotheses and we are ready for the next step. Our materials, which you still should have. No, you don't need to write the reaction down, Elizabeth. We should have 4 Alka-Seltzer tablets, 4 clear glasses, a watch with a second hand, a thermometer, a spoon, room temperature water and ice temperature water, or ice water, and then the warm water you should have gotten already. So what we are going to do is first we will take a regular room temperature glass of water. Take the temperature of the water using your thermometer and write it down. If you do not have a thermometer, write room temperature next to it. You can still do the lab, it just won't have temperatures associated with it. So, for instance, the temperature of my water is about 15 degrees Celsius. So I'm just on my scrap piece of paper that I have. I'm going to write 15 degrees Celsius room. Just like this. Now, drop 1 Alka-Seltzer tablet into the water. Measure the amount of time required for the reaction to be completed. Your reaction is complete when the bubbles stop. So don't drop your tablet in until you are ready to start your timer. Once you are ready to start your timer, drop it in and you are going to watch until the bubbles stop. Anyone have any questions before you do that? Mallory, go ahead. Make sure you're clicking the talk button, Mallory, because I did not see that she clicked it.
I'm not ready. I'm a little bit behind. Because what do we do?
Right now, all you've done is you have a half a cup of water in a cup, and you've measured the temperature. That's the only step you've done so far. Okay, are you to that point?
Room temperature, hot water, ice water. I'm confused.
Right now, we're just doing room temperature water. So are you ready with your room temperature water?
No, I still have the glass that has the Alka-Seltzer tablet in it.
Okay, well go ahead and grab a new glass of water. I just did that Alka-Seltzer tablet as a demonstration to you guys. You guys haven't added any tablets to your water yet. Okay, right now you should have your glass of water and your tablet separate from each other. Yes, Elizabeth, we are only going to use one tablet at a time. And everyone's results may be a little bit different because my water was 15 degrees Celsius, but maybe Elizabeth's water, her room temperature water, may be 18 degrees Celsius. I have a well, so my well water tends to be much cooler than someone who may have city water. I have original strength Alka-Seltzer. Someone else may have maximum strength Alka-Seltzer. So while all of the results will not be the same, Brooklyn's will be different than Elizabeth's, Shelby's will be different than Mallory's, Elizabeth's results should be consistent. Mallory's results should be consistent. All right, so raise your hand if you still need time to get your room temperature water and your tablet ready. All right, so what we're going to do is we are going to drop our tablet in and hit your stopwatch and time until the bubbles stop. My tablet has stopped. If yours is still going, please keep timing. All right, everyone finished their room temperature. So now on your piece of scrap paper, you should have, let me back out a little, room temperature. You should have the temperature your water was. Mine was 15 degrees Celsius. Your thermometer may have been Fahrenheit. Make sure you figure out which it is. And then mine took 62 seconds. Make sure you have recorded how long your tablet took to dissolve. And that's the first part of our investigation. The second part of our investigation is to do the activity with ice water. So, you are going to take your clear glass and you are going to add ice cubes to it. We are going to give our water a little swirl so that it becomes ice water. Note, do not stir with your thermometer. You are now going to read the temperature of your thermometer in the ice water and record the results. If the temperature is still dropping and your red line is moving on your thermometer, make sure you wait until it's at a constant temperature. The temperature of my ice water is 7 degrees Celsius. Once you have recorded your temperature, you are going to take a different tablet, because your first one is now dissolved, and you are going to drop it into your cup of water. Start your timer. And see how long it takes for the bubbles to stop. Mine is still going. Still going. Still going. All right, mine has just stopped. If yours is still going, please continue to monitor. Okay, once you're done with the ice water, go ahead and hit yes when you're ready to move on. Okay, I'm just waiting for 2 more people. When you're all set, if you could just click yes for me. That way I don't lose anybody. All right, fantastic. That was step number 2, or part number 2. And here goes part number 3. We are going to take our warm water. When you measure the temperature of your warm water, please make sure that it is at least 3 degrees warmer than your room temperature water. If not, please go heat your water up again. Mine is almost 10 degrees hotter, so you should be fine, but if not, go heat your water up again. You are going to follow the same procedure. You are going to take the temperature and record it. Mine is at 24 degrees. Remember, if you're using a Fahrenheit thermometer, your temperatures are going to seem way higher than mine. You then are going to take a new Alka-Seltzer pill, drop it in, and record your time. So go ahead and do that for the warm water. Mine has just stopped. Alrighty, once you've recorded that time, please go ahead and click yes for me. I'm glad you liked it, Brooklyn. And we're not even done. Well, we're done with the experiment part, but we haven't even talked about it. All right, well, while we're waiting for the last person to finish up, why don't we talk about our results? Now, I'm going to hold my results up to the screen. I had room temperature water taking 62 seconds, the ice water taking 160 seconds, and the hot water taking 40 seconds. So what happened? What were my results? How can I make any sense of that? Or how can you make sense of your results? As the water temperature, let's think back to my hypothesis. As the water temperature increased, so as it got warmer, the rate of my reaction, so how long the reaction took, did it increase, or did it decrease, or did it stay the same? Who can help me interpret my results? Anyone? A hint, your results were probably the same. What happened? Brooklyn, go ahead.
The water increased the temperature. It dissolved faster.
Awesome, great job. That's exactly what happened in my lab, and it sounds like that's what happened in Brooklyn's lab. Now the great thing about, now that I'm done, I can take my goggles off here. The great thing about science is if yours didn't work out the same, you have the data to back your experiment up. So that is exactly what happened in my lab, Brooklyn. But maybe it's not what happened in Shelby's lab for whatever reason. Shelby has her data so she can back up her information. So that is what should have happened. As the water temperature increased, the rate of the reaction should have increased. So great job if those were the results you got. This was sort of a practice lab to see how you guys could work through something. And the next step is we're going to write a lab report. Well, you are going to write a lab report, not we. Your lab report is your homework for this week. So when you log into Moodle this week, anytime after class today, you will see the PowerPoint we just followed for the lab. If you want to refer back to it, if you have any questions, you can just look right there. Everything we looked at today is on the Moodle website. You will also see an assignment. It says Homework Week 1. When you click on it, it says you will write a lab report on the investigation we did today in class. Well, you may be saying, I have no idea how to write a lab report. Don't worry, I'm going to show you. This document is up on the Moodle site as well, so you can look at it. But if you look right now on your PowerPoint screen, you should see something that says Lab Report. Just so we can all make sure we're seeing it, click yes if you see Lab Report document. Okay, it has 5 Roman numerals on it. And these are the 5 steps to the lab report I would like you to write. You can type your lab report, or you can handwrite your lab report. If you handwrite your lab report, you'll need to either scan it to me, or you can take a picture of it with your camera and send me the pictures so that I can read it. So the lab report, the first part, you have to give it a title. You can steal my title. You can make your own up to you. Your first Roman numeral is going to be your purpose. Write a description of the lab. What are we doing? Why is this lab being performed? This is where you are going to write your hypothesis that we made. Remember at the beginning I told you all to jot it down? Then you are going to, for Roman numeral 2, list the materials that you use in the lab. Then you are going to write your procedure. What did you do? Then in step 4, you are going to write your results. That's where you're going to put your data. And in step 5, you're going to write your conclusion. The conclusion was what Brooklyn just told me. As the temperature of the water increased, the rate of the reaction increased. That's it. That's a simple conclusion. And then you're going to submit this to me under homework week 1. If you start working on your lab report and you have any questions, call me or email me and we can work through them. If you have problems submitting your homework on Moodle, same thing. Call me and we can work through it. Okay, it's a little bit after 1. Sorry we ran late. If you have any questions, I'll stay on for a couple of minutes and answer them. Otherwise, homework is due by 9 a.m. Eastern Time next Monday so that I can look at it before class. And I will see you next week at noon Eastern Time. You will get a new invitation for class that will say Kitchen Chemistry Week 2 on Friday. So if for some reason you don't get the email on Friday, please email me or give me a call. I hope you guys have a great week, and I will see you next Monday. Have fun!